Hello everyone, welcome to my YouTube channel. Today I will explain exercise, and my voice is a little bit different from my voice in the previous videos because I had braces. And well, let's get it started. Exercise: determine whether any of the angles of triangle M1, M2 and M3 is obtuse. Firstly, what is obtuse angle? Obtuse angle is an angle with greater than 90 degrees. And so let's find, and this is the coordinates of the points. Solution: firstly we have to draw a triangle. For example, this is our triangle. Point M2, the coordinates of the point M2 is 0, 7 and -4, and the coordinates of point M1 is 4, -1, 4. The coordinates of the point M3 is 3, 1 and -2. And yes, M1, M2 is a vector, and M1 and M3 is a vector. For example, vectors M1 and M2 and M1 and M3 form an angle M1. We can define and call this angle alpha. And yes, we can call the vector M1, M2 as a vector, and we have to find the coordinates of the vector A. In order to find this, we have to subtract the coordinates of the point M2 and coordinates of the point M1. 0 minus 4 is -4. 7 minus -1 is 8. -4 minus 4 is -8. And the model of vector A is equal to the model of vector M1 and M2. This is equal to square root of -4 squared plus 8 squared plus -8 squared. This is equal to 16 plus 64 plus 64. This is equal to square root of 144, and this is equal to 12. Sorry, that's 12. And the vector M1, M2, we can call this B vector. For example, this is vector B. And in order to find the coordinates of the vector B, we have to subtract the coordinates of the vector points. 3 minus 4 is -1. 1 minus -1 is 2. And -2 minus 4 is -6. And yes, this is the coordinates of the vector B. And the model of vector M1 and 3 equal to model of vector B. And yes, this is equal to square root of -1 squared plus 2 squared plus -6 squared. This is equal to square root of 1 plus 4 plus 36. This is equal to square root of 41. And the scalar product of vectors A and B, this is equal. Scalar product of the vectors A and B is equal to the vectors -4 plus times -1 plus 8 times 2 plus -8 times -6. This is equal to 4 plus 16 plus 48, and this is equal to 68. Yes. And the cosine alpha is equal to scalar product of the vectors A and B and over the module of vector A times the module of vector B, and this is equal to the scalar product of the vectors A and B is 68. The module of vector A is 12 and the module of vector B is square root of 41, and cosine alpha is greater than 0, then this angle is acute angle. Acute angle is an angle that has degree less than 90 degrees. And let's continue. This is our triangle and the points M1, M2, and M3. Coordinates of the point M1 is 4, -1, 4. The coordinates of the point M2 is 0, 7, -4, and the coordinates of the point M3 is 3, 1, and -2. So we also call the vectors M2 and M1 and M2, M3 form an angle beta, and we can call the vector M2, M1 as a vector A, and in order to find the coordinates of the vector A, we can subtract the coordinates M1 and M2. 4 minus 0 is 4, -1 minus 7 is -8, 4 minus -4 is 8. Yes, and we can call also M2, M3 vector as a B vector, and the coordinates of the vector B is 3 minus 0 is 3, 1 minus 7 is -6, and -2 minus -4 is 2. Yes, and the module of vector A is equal to square root of 4 squared is 16 plus -8 squared 64 plus 8 squared is 60, and this is equal to square root of 144. This is equal to 12, and the module of vector B is equal to 3 squared plus -6 squared plus 2 squared, and this is equal to square root of 9 plus 60 plus 4, and this is square root of 49, and this is 7. Yes, and the scalar product of the vectors A and B is equal to 4 times 3 plus -8 times -6 plus 8 times 2. This is equal to 12 plus 48 plus 16. This is equal to, and this is equal to 76. Yes, cosine beta is equal to scalar product of the vectors A and B and the module of vector A times the module of vector B. This is equal to 76 over 12 times 7. This is greater than 0. This means angle B is acute angle, and acute angle is an angle as degree less than 90 degrees. Yes, and we learned that the angle beta is also acute angle. So we have to find the vector gamma also. The vectors m3, m1 and m3, m2 define an angle m3, and we can call m3 angle as gamma angle, and the vector m3, m1, we can call this angle as a vector. The coordinates of the vector A is 4 minus 3 is 1, negative 1 minus 1 is negative 2, 4 minus negative 2 is 6, and the module of vector A is equal to square root of 1 squared plus negative 2 squared plus 6 squared. This is equal to square root of 1 plus 4 plus 36. This is equal to 41. And the vector m3, m2, we can call this angle as a b. We can call this angle, this vector as a b vector, and the coordinates of the vector b is 0 minus 3 is negative 3, 7 minus 1 is 6, negative 4 minus negative 2 is negative 2, and the module of vector b is equal to square root of negative 3 squared plus 6 squared plus negative 2 squared. This is equal to square root of 9 plus 36 plus 4, and this is square root of 49. This is 7. Scalar product of the vectors a and b equal to 1 times negative 3 plus negative 2 times 6 plus 6 times negative 2, and this is negative 27. This number is negative number. This means that the gamma angle is obtuse angle, because cosine gamma equal to scalar product of the vectors a and b, and the over module of vector a times module of vector b. The scalar product of the vectors is negative 27, and the module of vector a is positive number square root of 41, and the module of vector b is 7, and the cosine gamma is negative number. This means the angle gamma is an obtuse angle, which means has degree greater than 90 degrees. And we learned that which angle is obtuse angle. We learned that the angle alpha and beta are acute angles, but the angle gamma is obtuse angle. In this picture, this doesn't seem like an obtuse angle because I draw it just in case, and this is not the triangle in this situation exercise. So that's all. Thanks for watching my videos. Please subscribe to my YouTube channel, like my videos, and leave a comment to support me. Thanks for watching. Thank you for watching.